Hi, I'm Lisbeth, and today we're going to be going over molarity. So molarity's symbol is actually going to be a big M. Pretty simple, right? And how do you find the molarity? Is going to be finding the moles of the solute over however many liters of solution you have. Alright, so we have to keep that in mind because it's going to be very helpful with these two problems that I have on the side of the board. Alright, so molarity is just a measurement of concentration of whatever it is that you're looking at, and we use it a whole lot in chemistry, especially in labs, because you're going to pick something up and it's going to say that it's like 0.5 molar, and you have to understand what that is and how it's going to react. So let's figure out how we can actually find the molarity first. So this problem is actually number 69 in the Ebbing and Gamble book, and it says an aqueous solution is made from 0.798 grams of potassium permanganate. If the volume of the solution is 50 milliliters, what is the molarity of potassium permanganate in the solution? So here I just wrote down what was given to us. They gave us the grams of potassium permanganate, they gave us the volume in milliliters, and they're trying to ask us how to find the molarity. So you're looking at this and you're like, wait a second, I don't see moles, I don't see liters, how are we going to find this? So it's pretty simple, right? We're going to go ahead and take the grams and convert them to moles using our molar mass, and we're going to take that volume and convert it from milliliters to liters, and then we're just going to divide. So let's see how that actually looks. Alright, so we're going to start off, I'm going to go ahead and convert the moles first. So I'm going to start off with the 0.798 grams of potassium permanganate first. Now, if I have grams on the top, I have to put grams on the bottom so that they cancel out. So I always like to put my units first so that I don't get confused, okay? So grams of potassium permanganate, and then it's going to be in 1 mole of potassium permanganate. It's in 1 mole because whenever you're doing molar mass, it's just always going to be grams per 1 mole. So I went ahead and found out the molar mass for you. How you would find that is that you would add 1 potassium, 1 manganese, and then 4 oxygens together. That should give you around 158.03. Depending on your periodic table, it might be a little off, but should be relatively the same. When you divide these two values together, you're going to get 0.00505 moles of potassium permanganate. And I know it's going to be in moles because remember, my grams canceled out. Okay? So now I have moles, I'm halfway there. I just need to convert my 50 milliliters into liters. So we've learned that, right? So we have 50.0 milliliters. And there's 2 ways you can write this, and I'm going to write them both ways. So you can say that there are 1,000 milliliters in 1 liter. And again, I put milliliters on the bottom because I needed to cancel out the top. And that'll give you your answer. Or you can write it in another way if you feel more comfortable. Is to put the exponent with the base. So it would be 10 to the negative 3 liters and 1 milliliter. They're both going to give you the same exact answer, so just do whatever you feel comfortable with. So the answer I get for this is 0.0500 liters. Alright, so now that I have moles and I have liters, I can just divide the two and then we're done. So I'm going to go ahead and divide 0.00505 moles by the 0.0500 liters, and that gave me 0.101, and that's going to be of potassium permanganate. So the answer for that, the molarity of this this solution would create, is 0.101 molar potassium permanganate. So that's how you find molarity when you're given grams and volumes that's not in liters. This one's a little trickier. Since molarity has more than 1 unit, it has moles and liters, it can be used as something called a conversion factor. So if we have liters, for example, of something, I can go ahead and convert to moles using this as a conversion factor. Very similar to how you would use a balanced equation and using those coefficients as a moles-to-mole ratio, you can use that you're converting from moles of one substance to moles of another substance. You can use molarity to convert from moles of something to liters of something, or vice versa. So here I kind of have an example of that, and I'm going to show you the thought process behind of how to get to milliliters, okay? So let me explain why we're going to start off with grams, right? So this is going to be our molarity, and our molarity is actually moles per liter, right? So in my head, whenever I see molarity like that, I have it in the back of my mind that this is actually 0.17 moles in 1 liter. And why in 1 liter? Because if I had more than 1 liter, it would no longer be 0.176 if I divided it. So I know that this is the ratio. For every 0.176 moles, I have 1 liter. For every 1 liter, I have 0.176 moles. So now that I see that there are moles there, and I see grams, it instantly clicks, oh, I can just convert the grams to moles, and then use this to convert to volume, all right? So let's go ahead and do that. So we're starting off with 0.0353 grams of KOH, and then we'd use the molar mass. So I went ahead and found that out for us as well, and I found that to be 56.106 grams of KOH in 1 mole. Now, that would give me moles, correct? So now my grams canceled, and I'm just going to keep going on with this example. So next, I canceled out my grams. Now I'm in moles. So I can use the 0.176 moles and put 1 liter of KOH on the top, right? And that would leave me in liters. And from liters to milliliters is very, very simple to do. So let's just do that at the end. Let's just tack that on at the end. In 1 liter, I have 1,000 milliliters. Again, you don't have to write it this way. You can write it this way. It's going to give you the same exact answer. So my final answer there was found to be 35.7. So the reason this works is because the grams would cancel, the moles would cancel, the liters would cancel, so you're left with milliliters on the top. And yes, so that means in words, if you had to write a sentence, that in order to get a molarity of 0.176 molar KOH, I would need to combine 0.0353 grams with 35.7 milliliters, and that is what would give me that molarity. So that's basically molarity. Remember that you can use it, you can find it, but you can also use it as a conversion factor. This here is very, very, very common, and we do it a lot to be able to convert between a measurement of mass to a measurement of volume. This is very, very, very common. So yeah, that's molarity.